My name is Jonathan Coti, and I'm an application engineer for Pottorff. I've worked for Pottorff for about 11 years now, and most of my time at Pottorff has been in the design role, but more recently in an application engineer role. So this webinar here is to review Pottorff's industrial control dampers. So if that's what you're expecting to learn about today, then you're in the right place. And for the past couple of years here at Pottorff, we've made a huge effort to really increase our industrial damper selections. We know we've had some pretty big gaps in our product lines, and we've tried really hard these past few years to fill those in. So there are still some ongoing industrial damper projects that we're working on, but we wanted to give everyone an update and just a good overview of our industrial dampers that we currently have available, just in case you didn't know of any new products that we've come out with. So in our presentation, I plan on discussing the application for industrial dampers. It's going to go into some general specifications that will allow you to know better when do you need an industrial control damper versus a commercial control damper. We're also going to discuss different construction, whether it's the blade type, material thickness, the paint, or the material type. We're also going to go look into the different damper types that we have, whether those are the true round, multi-blade, backdraft damper. And at the end of the presentation, we'll also be discussing some of our special applications, such as our fiberglass dampers that we've recently come out with. So the first thing that we're going to discuss is the application. So the general reason you would need a control damper, and this isn't specific to an industrial control damper, but this first part can take into consideration commercial or industrial. It's because it's a general control damper. So you would want to control at least one of these three items is why you would need a control damper. The first one is you're trying to control the air volume. You're wanting to control how much air is going in or out of a room or a building. So a lot of times you need these for smoke evac systems, tunnel dampers, or if you're just trying to get fresh air into a building or conditioned air into a building, that's why you would want a control damper. Another reason is to control the temperature in a room. So if a room's too hot, too cold, you're trying to get that conditioned air in, you would want a control damper. And also to increase or decrease the pressure in a building. It's too much pressure in a room, you want to relieve some of that pressure. You would need a control damper. So these are kind of the three general reasons why you would want a control damper. So now the next reason is why would you want an industrial control damper? So the type of the reasons you would want these are kind of three different reasons. So the first two are if the velocities or pressures in your systems are higher than what a commercial control damper can handle. Maybe it's the blade type, the blade thickness, or the frame thickness that doesn't allow the commercial control damper to withstand those velocities. So that's when you have to start going into an industrial control damper. As you're going to see, a lot of our industrial control dampers typically come with a heavier duty frame, heavier duty blade and axles and other components. Or another reason you might go with an industrial control damper instead of a commercial is because of the temperature range. So our commercial control dampers can only handle so much temperature because of how they're made. So a lot of times you need to go into an industrial control damper with high temp components. And then the general rule of thumb for medium to high pressure applications, which is our industrial control dampers, is when you start getting over 4,000 feet per minute or 5 inches of water gauge pressure, that's kind of the point when our commercial control dampers aren't able to withstand those kind of velocities. And so you need to start going into industrial heavier duty type of damper. And some of general tips for our industrial control and backdraft dampers. The multi-blade dampers can be installed vertically or horizontally, and the industrial backdraft dampers can only be installed vertically. Our commercial backdraft dampers can be installed vertically or horizontally, but that doesn't carry on over to our industrial backdraft damper. So make sure you install that properly. And the next thing we're going to look at is just the general construction of our industrial control dampers. The construction of our industrial control dampers most commonly vary from 14 gauge to 10 gauge, but some of the frames can go up to 3/16 inch thick. So you can always select different options throughout through specs also. Most of the dampers that come standard in painted steel, and the type of paint that we use is our high pro poly powder coat or a high temp powder coat for those higher temps that can go up to 450 or 600 degrees Fahrenheit. We also do have 304 or 316 stainless steel option for most of the dampers. And there are a few dampers that have aluminum material options. But there's not as many, but most of our dampers do have that 304 or 316 stainless steel option. And then we'll go into the four different types of blades that we use on our industrial control dampers. There are typically four different ones, which is the true round blade, the triple V blade, the steel airfoil blade, and aluminum airfoil blade. And our industrial control dampers, I had mentioned earlier, we use a lot heavier duty components, and that includes the linkage and the heavier duty axles. Some of our multi-blade axles go up to 1 inch, but even our true round dampers can go up to a 2-inch diameter for the axle. So it's where it gives you that strength and allows you to function during high pressure or high velocity systems. So now we'll go into some of our industrial true round dampers. And like I mentioned earlier, in order to fill the gaps in from our product line, we've really increased our manufacturing capabilities to really help produce some of these industrial true round dampers. As you can see in this image, these industrial true round control dampers will have a single blade that rotate around a solid axle. The axle itself goes across the entire blade and frame. And the frame will be flanged, and we have a standard bolt pattern that can be selected, but we do have options to customize the bolt pattern if there's a certain bolt pattern that is needed for the job. All of these dampers begin at a diameter of 4 inches and go up to either 60 inches or 72 inches in diameter. The CD81R goes up to 60 inches in diameter and has a max velocity of 4,000 feet per minute on the largest diameter, and it can go up to 6,000 feet per minute on the smallest diameter. The pressure rating can go from 6 to 10 inches of water gauge pressure, depending on the diameter that is needed. The maximum allowable temperature can vary depending on certain options that are selected, but it can go up to 400 degrees Fahrenheit. In the CD81R, the construction of it starts with a 12 gauge frame and a 10 gauge blade and a 1/2 inch axle. And the next one after this is the CD83R. CD83R can go up to a 72 inch diameter, so a little bit bigger than the CD81R, and it has a maximum velocity of 5,150 feet per minute. And the CD83R comes standard with an outboard ball bearing, and this allows it to withstand higher temperatures, which allows the damper to go up to 600 degrees Fahrenheit. The CD85R is the next one, and it can go up to 72 inches in diameter, but it has an increased velocity, and it can go up to 6,400 feet per minute and has a higher pressure of up to 20-inch water gauge pressure. The temperature for it can also go to 600 degrees Fahrenheit because it does also use the outboard ball bearing. And then the final one, we have the CD87R, which can go up to 7,000 feet per minute and has a pressure rating of up to 30-inch of water gauge pressure. And the reason we're able to go this high with this damper is because the axle itself starts off at a 1-inch diameter, and the blade begins at 3/16 inch thick, and the axle can go up to 2 inches in a 1/4 inch blade thickness. So as you start getting into some of these larger high velocity, we do increase the axle diameter, blade thickness, and the frame thickness. It kind of allows you to withstand that pressure. Now we're going to go into our multi-blade dampers. So there's 3 different multi-blade dampers that we're going to be covering, and the first one is going to be the triple V blade. So as you can see, the frame is going to be similar through most of our multi-blade dampers. The linkages are all going to be concealed on our multi-blade dampers, and they all come with a stub axle. So all the basic design of them is very similar, but the blade is what changes from damper to damper on these multi-blade dampers. The CD81, 82 are similar dampers, except the 81 has a parallel blade and the 82 uses an opposed blade configuration. The damper uses a 1/2-inch axle and has an option to be ordered with or without low leakage seals. The velocity rating goes up to 3,000 feet per minute and has a pressure rating of up to 10-inch water gauge pressure. It does come standard with a 14-gauge frame, but it does have an option to be ordered with a 12-gauge frame. And the blade comes standard at 16 gauge. And the next one is the CD8384. It has a higher velocity and pressure rating due to the 3/4-inch axles and thicker material that is used on the frame and blades. The velocity is able to go up to 5,000 feet per minute, and the pressure up to 15 inches of water gauge pressure. It comes standard with a 12-gauge frame and a 14-gauge blade. And both of these dampers do have low leakage blade seal options and a jam seal option if that's what the job requires. They also both have stainless steel options. And depending on the damper width and height, the maximum allowable velocity and system pressure do vary. So it's always good to double check the catalog to see what the requirements are for that job at that size, because it does vary. Next, we're going to go into our multi-blade steel airfoil blade dampers. So as you can see, kind of the channel frame, the stub axles, and the concealed linkage are very similar to the triple V blade that we just discussed. But the main difference is we start using a steel airfoil blade. It's a double skin blade. So we'll start off with the CD91, 92. The 91 and 92 both have the same options and components. The only difference being that the 92 is opposed instead of a parallel blade. And just wanted to point something out. As you can see, as a general pattern in our nomenclature, that we typically use an odd number for our parallel dampers and an even number on the opposed blade damper. So whenever you're looking at a lot of our dampers, just keep that in mind so you can know if it's opposed or parallel blade. The 91-92 series can go up to 48 by 96 and has a velocity rating of up to 4,000 feet per minute. The pressure rating can go up to 9 inches of water gauge pressure, and depending on the damper size. And it comes standard with a 14-gauge frame, but it does have an option to be ordered with a 12-gauge frame. And the blade comes standard at 14 gauge. The 93-94 is the next one we're going to cover, and it's more robust and can go up to 5,000 feet per minute and has a max single section size of up to 60 by 96. It can go up to 32 inches of water gauge pressure, and it comes standard with a 12-gauge frame and the 16-gauge blade with an option for a 14-gauge blade. And then if you need a larger section size that can withstand a similar velocity as that 93-94, you would go next to our CD95-96, which can go up to a single section size of 60 by 120 and can withstand temperatures of up to 450 degrees Fahrenheit. And it comes standard with a 14-gauge frame and a 14-gauge blade, and it does have an option for 12-gauge blades. And for the largest and highest velocity damper that we have is the CD97-98. It's able to function to pressures of up to 6,000 feet per minute and 45 inches of water gauge pressure. It can also withstand temperatures of up to 450 degrees Fahrenheit. It comes standard with a 10-gauge frame and a 12-gauge blade, and has an option for a 10-gauge blade. And it comes standard with a 1-inch axle. Next is going to be the aluminum airfoil blade. So our aluminum airfoil blade, again, all comes with a channel frame, stub axles, and concealed linkages similar to our other multi-blade dampers. The main difference being that the blade is an aluminum extrusion. The CD 103-104 uses a 3/4 inch axle and goes up to 60 by 96 and can be used on air velocities of up to 5,000 feet per minute. The pressure rating is of up to 15 inches of water gauge pressure, and it can withstand temperatures of up to 450 degrees Fahrenheit. The 103-104, it does have an aluminum frame option, but it also has a 304 and 316 stainless steel option similar to our other dampers that we saw earlier. And then the second section on this is the TD9394. And it's an industrial control damper that is specifically engineered for transit tunnel systems that will require tight shutoff or high velocity and pressure. The 9394 meets requirements for strength leakage and operability in accordance with our NFPA 130, 502, and UL 555S. It also has material options for the frame and blade to have a 304, 316 stainless steel option for these. Again, I want to remind everyone, if you have any questions during the presentation, you can message us on the chat box, or if you want to wait till the end of the presentation, we'll have some time for some Q&A. Now we're going to go into our industrial backdraft damper. The industrial backdraft damper is composed of triple V blades and has an adjustable counterweight that gives you the adjustability to increase or decrease the amount of pressure needed to open or close the damper. It can only be mounted in a vertical position and has a maximum size of 48 by 96. We do have the option for neoprene blade edge seals, but once you start using the neoprene material, it does decrease the allowable temperature to go from 150 instead of the 250 without seals. And it does come with a 304 stainless steel construction option on it also. Next, we're going to look into our special applications. The first one we're going to look at is the BC550. It's the blast damper, and it's designed for protection against blast and instantaneous pressure changes. The maximum allowable pressure is 15 psi, and the type of application is usually used in is government buildings, mining, and oil and gas refineries. Next is our bubble tight damper, the CD95R, and it's meant to be used on low leakage or zero leakage applications up to 30-inch of water gauge differential pressure. So these are meant to be used in industrial processing plants, laboratories, clean rooms, pharmaceutical facilities, and nuclear facilities. So the cool thing about the CD95R is that we cycle and test every damper that comes on our line to make sure there are no leakage points in the blade to frame or in the axle. And the reason that it's called the bubble tight damper is because we pressurize the damper up to that 30-inch gauge pressure, and then we spray a bubble solution on it and check, make sure there are no possible leakage points. If at any point there is any leakage points, we rework it, make sure there's no leakage points, and then test it again. Some of the options for the bubble tight damper are 304 and 316 stainless steel. And we do have a few different actuation types that can be used for the bubble tight damper. It can use the locking quad, hand wheel, and we also have multiple actuator options. I know there are many specs that call out spring return actuators for bubble tight dampers, but I just want to ask everyone, always make sure that if you do order it with a spring return actuator, please make sure you do need a spring return actuator, because the spring return actuators significantly increase the cost of the damper. The motor itself on the actuator has to overcome the spring, so it increases the motor strength, which in turn increases the actuator size and the cost of it. So that's always something to be on the lookout for. The last special application that we're going to be covering on this slide is a tornado damper. And it's very similar to the blast damper. It typically allows normal air intake and exhaust during typical conditions, but once it sees a sudden negative pressure of up to 3 psi, it closes and protects everything behind it as your duct or HVAC system. We're going to continue on to more of our special applications, but it's going to be our fiberglass damper lines. So we have multi-blade, true round, and backdraft dampers that are all fiberglass. And fiberglass dampers are good for highly corrosive environments such as wastewater treatment plants, microelectronics manufacturing, marine environments, and just where there's a significant exposure to moisture and salt. So we're going to start with our multi-blade fiberglass damper. The FRP 8182, it uses a triple V blade and can be ordered up to a 48 by 72 single section size, and can withstand velocities of up to 2,000 feet per minute, and has pressure ratings of up to 20 inch of water gauge pressure. Some options for this damper consist of low leakage seals for the blade and the jam. And then the next one is the FRP 9192. It's similar to the 8182, but instead it uses an airfoil blade, and it can also be ordered up to 48 by 72. But it can withstand velocities of up to 4,000 feet per minute and pressures of up to 28 inches of water gauge pressure because of the more robust airfoil blade that it's used on it. The next fiberglass damper that we're going to be discussing is our true round fiberglass control dampers. The FRP 81 can be ordered up to 48 inch in diameter and has a velocity of up to 2,000 feet per minute and 5 inches of water gauge pressure. And then we have the FRP 83R. It's a little bit more robust. It has those flanges around the frame, and it can be ordered up to 72 inch diameter and can withstand velocities of up to 6,000 feet per minute and 10 inches of water gauge pressure. It also has options for shaft seals, blade seals, and it has an option for 3/16 stainless steel axle option. And then the FRP 85R is similar to the 83R, but it increases material strength. But the increase in material strength allows it to withstand velocities of up to 6,000 feet per minute and 30 inch water gauge pressure. We have a question here. How about a round stainless steel backdraft damper? Yeah, that is something that is on our list for production for our new product development. We don't have a round stainless steel backdraft damper. Right now, we just have a rectangular backdraft damper, and it's also not stainless steel, but it's something that we can definitely look at. And going on to the another thing I wanted to bring up on the fiberglass damper, as you can see, the temperature ratings across these is between negative 20 degrees Fahrenheit to 200 degrees Fahrenheit. And most of the limiting factor for this fiberglass material is the fiberglass itself. And that's why it's pretty consistent across our fiberglass dampers. Now, the last section of our fiberglass dampers is the backdraft damper. The FRP BD84 is the triple V blade, and it can withstand a velocity of up to 2,000 feet per minute and 10 inch of water gauge pressure. It has a low leakage blade seal and jam seal option. The FRP BD94 uses an airfoil blade and allows it to withstand up to 4,000 feet per minute and 16 inch of water gauge pressure. So same options it has the same option, but it also has a shaft seal option for it. And then the FRP BDR, it's a true round backdraft damper. It can be ordered up to 48 inch diameter and can withstand of up to 6,000 feet per minute velocity and 10 inch of water gauge pressure. This has options for shaft seals integral to the bearing and also outboard bearings and blade seals. So, and all of these dampers come with counterweights that are adjustable on the arm, so it can open at a lower pressure or a higher pressure if that's what's required. And then another special application that we're going to look at is our thermally broken dampers. So the reason that you would want a thermally broken damper is similar to a control damper, but what these dampers also do is limit the transfer of heat going into or out of a building. So it allows you to isolate the low temperature process all the way down to negative 100 degrees Fahrenheit. These dampers are pretty versatile and can be installed in vertical or horizontal positions. We also have a few variations of the thermally broken dampers, and they can be ordered with thermally broken blades, thermally broken frames individually, or with both options on the same damper. These dampers are also AMCA certified with leakage and thermal efficiency, if that's for some of these dampers. Now we're going to go into discussing all the different thermally broken dampers that we have. As you can see, I want to point out the velocity ratings and pressure ratings for these different type of dampers are all the same. And the reason it's like that is because the dampers are all aerodynamically similar, which means the shape of the blade and the frame are similar. What makes them unique is the location of the thermal brakes placed throughout the damper. So we'll start with the TICD 5152. It has thermally insulated and broken aluminum airfoil blades. The thermal break means that there's a gap between the aluminum material airfoil blade that is replaced with insulation. This allows the thermally insulated blades to reduce the heat transfer of heat and cold, and also helps reduce condensation. The temperature rating for this one is -45 to 212 degrees Fahrenheit, and it covers most of the needs. But for colder temperatures, we do have the 5152 BF, and this damper does not only have a thermal break on the blade, but it also has a thermal break on the frame. This allows the heat or cold transfer to be reduced even more than the 5152. And it can go down to temperatures to -70 degrees Fahrenheit. And like I mentioned earlier, because these dampers are aerodynamically similar and velocity and pressure ratings are the same as the 5152. Finally, we have the 51BFX, 52BFX. This damper has a thermal break on the aluminum blade and frames also, but is able to go down to temperatures to -100 degrees Fahrenheit. And for those lower temperatures, if that's what's required. And again, these dampers are all AMCA certified, and they all comply with the IECC, which is our International Energy Conservation Code. And the reason we're able to do that is because these have a leakage rating of 3 CFM per square feet at 1 inch of water gauge pressure or less, which is the best leakage rating class damper that you can have. So this covers our industrial control dampers and special application dampers that we're covering for this presentation.